Hi all, myself Mohan Kumar. Welcome you all for DataSphere YouTube channel. Let us explore some of the important unique key features of PostgreSQL DB. We're going to cover different topics which we are going to explore in detailed way: architecture, schema management, backup and recovery, performance tuning, standby and replication, and clustering. Let us look into these components in a way where PostgreSQL can accommodate RDBMS data and also NoSQL data seamlessly. At the same time, how unique it is comparing it with other popular RDBMSs. So PostgreSQL has become alternate to those RDBMSs. So let us look into some of the important features, uniqueness in architecture, database architecture, and we'll also look into that in schema management. In RDBMS, importance is given for schema. In NoSQL, importance is not given for schema. There is no schema, it's schemaless. And in RDBMSs, importance is given for backup and recovery. In NoSQL databases, it is least preferred. So we get performance tuning facility in PostgreSQL DB. Okay, so similar to what we can do it with other database, like for example Oracle database. And we got high availability configuration. So one is standby. Extended to that is replication. So which is supported. So the high availability configurations are supported in RDBMSs. So in NoSQL databases, they are the default type of configurations supported. So in RDBMSs, it is considered as complex, time-consuming, cumbersome to implement standby and replication. But okay, if you consider NoSQL databases, they are simple and easy to configure and use standby and replication. So one more feature is clustering. Is clustering supported in PostgreSQL DB? So yes and no is the answer. So no for it doesn't have native software, but using third party it can be done. So these are some of the areas of features. Let us look into architecture part first. So when you consider architecture, PostgreSQL DB. So PostgreSQL DB itself is not the database within which you will have smaller databases. Okay, so PostgreSQL DB itself is not a single database. So in fact, it is considered as database cluster. What is meant by database cluster is group of databases. It is a group of databases. So within which we'll have smaller databases, default and non-default databases. So one such database is Postgres database. The database to which we connect by default will be available when we provision PostgreSQL DB. So we'll get Postgres database to which we connect by default. We can create as many databases we need for our purpose. Okay, and we'll be able to store objects in that actually. Now, what is that difference here is? See, we'll have same concept with other RDBMSs also. If you consider MySQL database, there also we call them as databases or schemas in which we'll store objects. And if you consider SQL Server, okay, we'll have a system database and we create our own database to store our objects. And if you consider Oracle, even if you go for single database environment within which we'll have table spaces where system table space is meant for storing data dictionary objects. Even if you go for multi-tenant database, okay, we'll have container and pluggable databases. Pluggable databases are the databases in which we store data. So even there we got multiple databases concept. What is the difference is, if you consider Oracle pluggable database, it depends on container database. If you consider SQL Server, okay, so whenever you create your own database, so the metadata will be stored in system database. And whenever you go for creating and using a database in MySQL, so the metadata will be stored in information database or sys database. Means there is a dependency of dependency with the other database objects also. But if you consider PostgreSQL DB, it is unique. Okay, suppose assume that we got a database by name DSDB. We'll have two categories of objects. One is the catalog objects, okay, in which metadata information will be stored. Which metadata? Metadata about the objects stored in the same database. So it might be tables, indexes, which are the tables and indexes. So these objects will have their own metadata within the same database itself. So will not have any relationship with any other object of other databases. There's no possibility actually. There's no relationship between objects of one database to another database. So this uniqueness means each database is self-contained, as if it is a single database. Okay, as if it is the only database available. So it will be used actually as an isolated database. So means we can connect to DSDB only, and we can continue to use DSDB only as if that is the only PostgreSQL DB we got, because that will not have any dependency on any other database. That's why PostgreSQL DB is called as database cluster, group of databases in which we can use a database to store your objects. You can create as many databases you need depending on your requirement, and each database is self-contained, means will not have any relationship outside the database. And when it comes to the other part, service or instance, so it will behave as both actually. So when we say service or instance, so it's a combination of memory structures. Okay, it's a combination of memory structures, because you know that what are the data stored in database, physical files, so will be processed only in memory structures, and okay, we'll have background processes, so where they do specific activities. Okay, so here is a combination actually, is a combination. Generally we call it as instance. Generally we call it as instance. Instance is a combination of memory structures and background processes supported by PostgreSQL DB, and similar to, okay, so NoSQL databases. So PostgreSQL DB supports service also. You can call it as service or instance. It will behave as both service as well as instance. Is uniqueness. So similar to RDBMS, we call it as instance, combination of memory structures and background processes. We can customize them to suit our requirement. So which is not possible with services actually. When you go for a service, you don't get flexibility to tune individual components of the service like memory or processes. But here, as we are going to use them as instance, so we'll have flexibility to take care of individual components also, be it a different type of memory structures available, which we will discuss in detailed way in architecture. So means database wise, what is uniqueness is self-contained database. So each database is isolated from other databases, will not have any dependency with objects of other databases. So, and users will be able to connect to only database they want to connect, and they can work with only that database. And all those data of users applications will be stored in database, and those related information about the objects and data will be stored in metadata objects in the same database. We call them as catalog objects. Each database will have its own catalog plus data. And when it comes to service instance, it behaves as both instance, memory structures and background processes, where we can use them effectively. Service wise, it will act as a single thread for communication channel, so it will behave as both. This is also uniqueness. So generally when you go for RDBMS, either we use instance or service. If you take NoSQL databases, we use service only, but here it behaves as both service as well as instance. This is the uniqueness with respect to architecture. So each of these components, so we'll understand them in architecture in detailed way. So this is the uniqueness in architecture when it comes to a feature, an important feature actually. So next feature is schema management. Next feature is schema management. So when it comes to schema management, in RDBMS we give importance schema. What is a schema is? So schema is a structure, a logical entity you can consider. Okay, you can consider a logical entity. So within which we store objects. Okay, we store objects, be it tables, indexes, temporary tables, or any type of structures actually. So, and these objects are owned by user. So schema is nothing but a logical entity within which objects are stored. So, and users can own those objects. And whenever we go for PostgreSQL DB, we connect to a database. In that database, we store objects like table or indexes or any other type of tables. By default, they will go to a schema called as public schema. If required, So a separate schema can be created and we can use that actually. For example, project schema is created to store project objects. So in DSDB itself, we can store. So means user wise they connect to database. Okay, so and they connect to database and they store objects. In this database, so we can have multiple schemas possible. And one user, so typically if we take, can use multiple schemas also, provided that a user has got permission to use, can use multiple schemas. So if you, unlike Oracle, for example, where we'll have a schema by name of user, we'll have one schema for one user. Object shown by user is schema. But here in PostgreSQL DB, one user can use one schema, can use multiple schema. Schema name can be same as username or can be different also. So depending on requirement, within database, logically the objects can be separated depending on the requirement. Project related can be stored here, application related can be stored here within the database also. If required, you can go for different database also. DSDB is for schema objects. Okay, you can have a project DBA to store objects of a specific project. You can give a name. So each database is self-contained here. So within database, we'll have objects. So and those objects information stored in within same database itself in catalog objects. So but here when it comes to within database, we can have separate schemas. Logically, we can divide further so that we can store objects of specific requirement in schemas actually. By default, we always connect to public schema, or any user will connect to public schema and will use it, provided that user has got permission. So or else, okay, if you have created a separate schema for a specific user, can connect to that user, or for an user you can give access to multiple schemas also, or multiple schemas can be used by user to store objects. So these are we are going to do in PostgreSQL DB. So it supports schema. RDBMS supports schema, but if you consider NoSQL databases, there's no schema concept. So schemaless, they store objects in database. In PostgreSQL DB, what we are doing, fundamentally we are storing objects in database itself. Within that in schema, means it is going to follow both RDBMS facility wise support schema, and NoSQL databases wise it supports to store objects in databases itself, within the database itself. So how we can access an object is, we have to connect to a specific database itself to access the objects of any schema. So unlike Oracle, for example, where we can connect to a database and we can work with the objects of other schemas also, getting permissions, privileges. So here they are confined to one database only. Objects are part of a database. Within that database, we can subgroup them using schemas. So we can go for multiple such type of databases. Within each database, we can have separate schemas depending on our requirement. Data will be stored in respective objects like tables, indexes, and other structures, and its metadata will be stored in catalog objects. We call them as catalog here. Catalog objects will be stored, and these are independent databases, so they will not have any dependency on any other databases. Each database is self-contained, and to access that, we got one instance. We can consider PostgreSQL DB is a multiple database environment with one service, one instance. So usually we'll have one database, multiple instances, but here multiple databases, one instance. So here we got each database is self-contained. We got instance, background processes, we got memory structures. Any processing of any data will happen only in the instance actually. Bring the data to memory structures and will be processed. And within database, we can have separate subgroup called as schema. So we can go for as many schemas we need. Default schema is public schema. So we know the uniqueness in architecture feature wise. So is a database wise is a database cluster. So means group of databases. So each database is self-contained, and the schema wise supports one or more schemas. Default is one schema, public schema. Multiple schemas can be used. So for one user can have access to multiple schemas also. And objects are part of database. Within that, a subgroup is schemas. In NoSQL databases, schema is not supported, schemaless. So similar to that, there what will happen, objects are stored inside database. Even in PostgreSQL, we store inside database itself, which is similar to NoSQL databases. But PostgreSQL being RDBMS supports schema also. Within database, it will go for subgroup called as schema. Next is backup and recovery. So RDBMS gives importance for backup and recovery. So similar to that, okay, even PostgreSQL also will do that. We'll give importance for backup and recoveries also. And when it comes to backup and recovery, so of databases, we can go for, we'll have PostgreSQL DB, and we'll have option of going for logical backup of our database. So we can do it in different levels. Logical backup is nothing but extracting the structure and content in the form of SQL statements. We extract the structure and content in the form of SQL statement. So in PostgreSQL DB level means taking backup of all databases. So, and we can go for database level, individual database level backup. So we can also go for individual table level backup. And we got plenty of other options, format and options available, which we'll discuss in detailed way in backup and recovery. But so flexibility is there for us to take backup. We can go for logical backup, and we can use it for restoration purposes. So if you require, you can also go for physical backup, copying the physical files of our databases. So and there we can do it in no archive mode or archive mode of our database, or we can go for offline and online backup depending on the requirement. We can perform manually, or we can use an utility to take backup also. We can take utility backup, utility based backup is also possible. So these are the options available. Means we got flexibility in taking backup, both logical and physical backup. As we got flexibility, obviously we'll get flexibility in recovering also. We can go for complete recovery, and even incomplete recovery is also supported, which is very similar to other RDBMSs. But if you consider NoSQL databases, give least preference for physical backup and recovery, or no preference for backup recovery. So there the importance is given for high availability configurations, which is also supported by PostgreSQL DB. Now, does PostgreSQL DB supports performance tuning? Yes, it supports. So is it important for us? Yes, it is important. See, we should get performance with its features, functionalities. With its features and functionalities, we should get performance. But okay, so sometimes we have to customize the performance to suit our requirement. So is that possible? Yes, possible. We can perform tuning of our database. So and the instance of service part also. We can tune database components, organize them. So IO tuning wise, we can take care of them. And any content that is stored, okay, we can also organize them. We can use different structures like indexes to gain performance. In fact, we got special type of indexes to gain performance, and we use them for special type of data that we want to store in PostgreSQL DB. So we got different type of tables to consider to tune. Okay, we can use different type of tables, organizing them well. Okay, so to suit our requirement, distributing IO also again. So we can tune database level, designing the database means layouting the database to accommodate the objects. Different type of objects are available, like different type of tables, different type of indexes are available. You use them in combination to gain performance. So, and is that performance optimal? We can also verify that, and we can bring in necessary measures to enhance performance actually. Same way, we can also go for tuning service wise or instance wise. Okay, so basically instance wise, because okay, service wise it is treated as one unit, but instance wise we got flexibility. We can tune memory structures. To suit our application requirement, because you know that any processing of softwares, data will happen only in memory. Okay, memory only is used, and here in PostgreSQL DB, we got different memory structures to accommodate the different type of data and process it actually. So, and when the requirement of processing a specific type of data is more, so then we can customize that particular component of memory to suit our requirement. So we can go for tuning memory structures, and we can also tune background processes, increase the number of background processes. So, or okay, we can customize them to suit our requirements, so that what will happen, we can gain optimal performance even by tuning service part also. So means we can tune both the layers, database layer by planning well, distributing IO, and okay, the instance layer, so by customizing the memory structures to suit the application requirement, tuning them, identifying the bottleneck and tuning them, and background processes to enhance the performance. So we can do that actually. So this is about performance tuning of database supported by PostgreSQL DB. We got different components to tune. So if you consider in that way, so Oracle gives you granular level of access to tune. Okay, so probably in RDBMSs, Oracle is the number one database which gives flexibility for us to tune. But at the same time, it has brought in a lot of automatic features which we prefer to use nowadays, so that okay, we can get performance through that also. So which is followed by PostgreSQL DB. We got flexibility in tuning different components to suit our application requirements. So we'll discuss about performance tuning in detailed way. So part of performance tuning. So next is with respect to standby replication. Standby is, we know that it is a copy of our database, and replication is what are the data that is there in one database will be shipped and will be applied on the other database. So it is a combination here. We can go for standby, extended to that is replication, replicating the data. So here one of the biggest advantage in PostgreSQL DB is there's no restriction for us to go for number of secondaries. We can go for as many we need. So we'll have a database. PostgreSQL DB. When I say database now, PostgreSQL DB. So it is entire. So including within the database. So initially it is a normal PostgreSQL DB. We have to convert that as primary database. This is a normal PostgreSQL DB, which we have to convert as a primary database. So we got a database PostgreSQL DB, which is initially a normal database. We'll see the stepwise. Okay, so in a detailed way. So how to convert a PostgreSQL DB as a primary database. Okay, we'll see. Initially it is a normal PostgreSQL DB. So we can go for as many secondary databases we need. Secondary databases are nothing but the standby databases. Standby is nothing but exact copy of our primary database. So when we call it as primary, only after we convert it. Only after we convert, we call it as primary database. Okay, we'll go for as many standbys we need. There's no restriction. If you take RDBMS, other RDBMSs, there are restrictions with respect to number of databases that we can have as standbys. But here there's no restriction. You can go for as many. Little limitations are there, which we'll discuss in detail way. So initially it is a normal PostgreSQL DB. So convert it as primary database. And okay, so we are going to build a secondary database, which is exact copy of our primary database. We're going to build it. Using the copy, we're going to build it. So one secondary database is sufficient. So why should we go for one more is the requirement. Now, whenever you go for a primary database, copy of our database is the secondary database. But what will happen is users connecting to primary will not just connect to read data, they may go for write operations also. Means connecting to primary, which is the regular database, production database. So the database to which users will connect, they perform both read write as well as read only activities. So write operations they are going to do. Write means they are going to modify. See, read only will not alter any data. They read the data available. That is fine. No issues with that. But okay, when they modify, the changes will take place. So those changes need to be shipped and they should be applied. They need to be applied, shipped and applied. So will be done part of our configuration. So these changes will be shipped and will be applied to the secondary databases. So synchronization will take place. So synchronization will happen. So which we are going to configure. For that case, again, the background processors will come into picture. Now, what is the use is, so when you go for secondary, one is high availability is the advantage, high availability. So means if something goes wrong with primary, you got secondary. That is one thing. Then performance is the other requirement actually. So you can go for performance also. So means you can avoid using primary for read only by redirecting the read only to one of the secondary. So now read only can happen on the secondary available. Okay, secondary available. So with this, what will happen? That much of load is reduced on primary, so that okay, write operation will get more resources. Performance is enhanced. But assume that okay, so we are using primary and secondary, fine. But there comes a requirement where we want additional resources. So then we can go for adding one more secondary, and we can use that for read only purpose. So but what is happening? Any change that is going to take place on primary will be shipped and will be applied on So changes happening on primary because users will be able to write operation can be done only on primary. So will be shipped and they will be applied to secondaries, all available secondaries. So we'll not go for too many also, but anyway, we can have as many secondaries we need depending on our requirement. So this is about replication and standby. So first is we go create standby copy of our database, then we go for replicating data. So changes. So that because of this, secondaries will synchronize with primary. So this is basically for high availability and performance. So next is clustering. So clustering supported by PostgreSQL DB. Yes is the answer, but no is the other answer because it doesn't have native facility to cluster. Cluster is nothing but grouping servers. Leveraging the underlying infrastructure capability is clustering. So when you go for cluster, we'll have multiple servers which we can use for our purpose. So we'll have server 1, server 2, server 3, server 4. So where each server will have its own processing capability. Okay, I'll just represent as P. Processors will be there, number of processors. So, and three key components of any server is processor, then memory is the place where the activity will happen. Memory is the only place where the changes or access of data will happen. So, and okay, more the memory is good. So whenever we consider to go for servers, okay, so we give importance for second importance for memory next to processor. Then we'll have storage. So each server will have its own storage, and for that storage, volume wise, okay, we'll have some volume and we'll get IO also. If you consider in that way, then we got 4 servers with their own configurations, 4 set of processors are available, 4 amount of memory is available, 4 volume of storage is available, and we get 4 IOs. Can PostgreSQL cluster? No. So if you consider NoSQL databases, they have got that capability. They can, in fact, clustering is default in NoSQL databases. So same database software itself used for clustering, but PostgreSQL doesn't have that facility. Even it doesn't have native facility for clustering also. We have to depend on third-party clusters or third-party clustering facilities. So where PostgreSQL doesn't have, which was the case with even if you consider Oracle, which is treated as one of the efficient RDBMS, okay, and it has got clustering concept, okay, in the form of rack. So for that, we need to go for grid infrastructure software. Additional software is required. So which was introduced in 9i as rack. But previous to that, we didn't have even that software for clustering. We used to depend on operating system dependencies. Operating system was used for clustering. So same is the case with PostgreSQL DB. So we don't have native facility with PostgreSQL DB. We have to depend on third-party softwares for that particular purpose. So if you consider the best way we can use PostgreSQL clustering, nowadays preferred used in many levels is in AWS we got Aurora PostgreSQL compatible database where we get clustering concept there. We can go for many servers and we can use them for our purposes. Based on requirement, we can use them for read-only purposes, and okay, if required, we can also use them for high-availability configurations also. So with that, okay, what is going to happen is we are able to leverage the infrastructure capability as available. So clustering is possible, but not with native software. We have to depend on third-party software. So this is about one of the clustering feature that is supported by PostgreSQL DB. We have explored the key features of PostgreSQL DB, starting from architecture to clustering, and we have understood okay, what are those unique components are there with PostgreSQL DB so that it is capable of accommodating both RDBMS data and NoSQL data. Now it's your time to like and share this video to your DBA friends, and also comment which is that specific topic you want me to present in next video. Thank you all. See you next video.